Hi, today we are starting Chapter 7, which is all about geometry. Geometry is a branch of math that relates to shapes. Section 7.1 is all about the area of parallelograms. So we're going to start with the basics and work our way to more difficult shapes. A polygon is a closed figure in a plane that is made up of three or more line segments that intersect only at their endpoints. Several examples of polygons are parallelograms, rhombuses, triangles, trapezoids, and kites. Basically, if you were going to talk to anyone on the street about a polygon, you would be referring to shapes. The area of a polygon is the amount of surface that it covers. You can find the area of a parallelogram in much the same way as you can find the area of a rectangle. Now we need to talk about a couple shapes here. First, we're going to draw a square, then a rectangle, and then we'll draw a parallelogram. So these all have different properties. They're very similar though. A square has all right angles. So those little boxes in the corner tell you those are right angles. A rectangle also has all right angles. A parallelogram does not necessarily need right angles. A square has all sides equal. That's what those dashes mean. All of them are the same exact length. A rectangle has opposite sides being equal. A parallelogram also has opposite sides being equal. So that's some important information about those shapes. Also, a parallelogram has parallel opposite sides. The word parallel means that those sides, if they were extended forever and ever, will never cross each other. They are moving in the same slope direction. Now I'm going to write the area formulas for each of these. What you'll notice about these is that you are multiplying two numbers, and that's it for the area, right? We're multiplying side times side. We're multiplying length times width. We're multiplying base times height. These are all just different variations of the same exact formula. And what they all have in common is that these sides, the length and the width, and the base and the height must create a right angle. And I'm going to go into that a little bit later. So here's just a reference again. For a rectangle, you are multiplying the length times the width. These are kind of interchangeable. You can call this the length and this the width as well. Okay, so here's the area of a parallelogram. Your formula is area equals base times height. The base of a parallelogram does not have to be horizontal, meaning side by side, side to side. Any side of the parallelogram can be the base. So you'll notice here, this is the base. This top piece could also be the base in this circumstance because I know opposite sides of parallelograms are equal. That's what I talked about up here. Now, in order to find the height, just like what I said before about all of these, they're all similar in that the two numbers you are multiplying together must create right angles. So we look for that little box to identify a right angle. The height creates a right angle with the base. Now, a good way to remember this is when you get measured at the doctor's office every year for your height. When your doctor measures your height, they start at the top of your head and they go directly down to create a right angle with the floor. They never measure you on a slant because that would add height, right? That would add to your height. So we want to look for that right angle for any of these shapes. Now, I'm very particular about how I want you to show your work for this. 3 steps must be shown. The first step is the formula that you're using for that shape. So first you have to identify what shape am I looking at. In this case, this is a parallelogram. It sort of looks like a rectangle, but it's slanted on a side. And you can see that the opposite sides are going at the same direction, the same angle. So I will use my area formula for a parallelogram, which is base times height. That's my first step. Second step is to plug in your base and your height, or whatever numbers you are given. In this case, I am given a base of 12, and I look for that right angle to determine what the height is. So that's the second step. Now you're going to multiply these together, and you get 168, and we label it meters squared. So that is the area, how much space is taken up in this two-dimensional shape. Area is always measured in square units. So whenever you're writing area, you should write whatever the measurement is squared. Okay, now let's do this one. We are only looking at the shaded portion of this, which is a parallelogram. So we will use our parallelogram formula. Now it's a bit tricky to see the height and the base creating a right angle. I see the right angle here, which tells me that this is going to be the height, and this is extending off of the base. Now up here is the base. We know opposite sides are equal. So I'm going to use a base of 4 and a height of 8.5. Again, we're looking for that right angle to be created by the connection of the height and the base. And this gives me 34 feet squared. Now, when you're doing these on your own, you can do a little grouping symbol to then show that you understand how to multiply these. With cross-canceling, and that's how you get 34. But what is required are the 3 steps, and then you can do your calculations however you need on the side. Okay, example 2. Find the area of the parallelogram in square inches. Okay, so we're going to start with our formula. Area equals base times height, and we want it in square inches. So instead of saying 2.5 feet, I need to create inches. Now I know in 1 foot, there is going to be 12 inches. So I'm going to multiply 2.5 by 12, and I get 30 inches. Same thing for this piece, 2 feet times 12 gives me 24 inches. So those are the numbers that I'm going to be using. Now again, we're looking for the connection of base and height to create that right angle. So I see the right angle over here. You can transfer it over here as well because these are parallel. Or you know that opposite sides of a parallelogram are equal. So I can also write 30 over here. Now what's most important is not that the base is at the bottom, but that the base and the height create a right angle. So the base is 30 and the height is 24. You can also rotate your paper if you're given paper or if you want to print out any worksheets while you're doing them at home. But you can rotate it if it's difficult for you to see the base without it being on the bottom. And that gives me 720 inches squared. All right, last example. The area of the parallelogram-shaped forest bordered by roads is 99,000 square yards. What is the length of the deer trail? Now, we know in a parallelogram we don't necessarily have length, but length can be interchangeable with base or height. In this case, we'll use it to represent base because we can see how tall this is. Okay, I know this is difficult to see, but here is the length or the base, and we see the right angle as well. So we start with our formula, base times height equals area, and we plug in what we know. In this case, we know what the area is. We know it's 99,000. We also know that the base is our unknown, it's the length, and the height is 660. So we plugged in our numbers after coming up with our formula. Now we solve. I see multiplication between those two terms, so I will divide by 660 on both sides. Those will cancel, and that leaves me with B equals 99,000 divided by 660 gives me 150, and I label it yards, not yards squared, because this is just a length. This is not an area. This is representing 150 yards for the length. And those are the notes for chapter or section 7.1, area of parallelograms.